In today's lecture, I'm going to be continuing to talk about present worth comparisons, in particular in the case where the alternatives involved have unequal lives. We saw in a previous lecture an example of a present worth comparison involving a manufacturer examining its material handling facilities. In the previous example, we had two alternatives, one of doing nothing with an annuity as being the cash flows involved, and a second alternative of building custom automated equipment with a service life of 10 years. Now, these two alternatives were fairly easily compared because we could choose a study period of 10 years and make a comparison directly. However, it's not always so easy to make such a comparison. It's very important that when you do a present worth comparison that the service lives of the alternatives are the same. Let's imagine, for example, you're looking at used cars. It's given a choice between a $5,000 used car that's in fairly poor shape and you expect to last, say 2 years, and a $10,000 used car that you might expect to last 5 years. Well, in terms of present worth, the $5,000 used car would seem to have a lower present cost. It's $5,000 versus $10,000. But might not be the best purchase because even though you're spending $10,000, the more expensive car can last longer. So to compare them properly, you've got to really look at the same period of time. So in this example, let's say that after some study of the marketplace, the manufacturer discovers a third alternative. To buy some standard automated equipment rather than the custom automated equipment that we were discussing previously. So with the standard automated equipment, we have a different cash flow structure. We've got a higher first cost, but lower yearly costs. And we'd want to, in order to fairly compare this alternative with the other two, bring it to a present worth. But the complicating factor here is that the life of this third alternative is 15 years. So we've got an alternative that has a yearly cost going on forever, one that has a cost that is associated with a 10-year life, and one that has a cost associated with a 15-year life. Now, it turns out there are two methods for dealing with this problem. The first one is called the least common multiple of the service lives method. The second one is called the study period method. When we did the first problem involving just the two alternatives, we chose a study period, if you like, of 10 years. And in fact, both of these can be considered choosing a study period. But the idea behind the least common multiple of the service lives method is to choose one that gives an even multiple of the service lives so that the present worth can be properly compared. Let me show how this works. Let's take a little chart here showing years. I have a little slide here overlaying that. Now you notice there's two lines in the slide. The lower one, which alternates in colors of orange and purple, and an upper one alternating in colors of red and blue. The one alternating in colors of orange and purple alternates every 10 years. So what you can do is imagine that for alternative number 2, you buy the custom equipment, use it for 10 years, and then it's worn out. You have to buy it again. Use it for 10 years, and it's worn out, and buy it again. Use it for 10 years and worn out. So we're alternating every 10 years. You're purchasing a new set of custom equipment, exactly the same as the set you bought before. And the upper line represents the same principle for alternative 3, except here you're repeating the purchase every 15 years. So every 15 years, you're going out and buying exactly the same setup for the material handling that you bought 15 years ago. Now eventually, these cycles coincide. And you see, in fact, it happens here at the 30-year mark. It also happens again at the 60-year mark. And what it means is that if we took our study period at 30 years, and we recognize that within those 30 years, we're, for alternative 1, just doing using labor at $9,200 a year for the 30 years. For alternative 2, buying that custom equipment 3 times, once now, once 10 years from now, once 20 years from now. And buying the standard equipment twice, once now and once 15 years from now. We can have a period of time which is then comparable for the 3 alternatives, because we aren't left over at the end of whatever period with equipment that still has value to it. If we find the present worth of the 3 alternatives over that 30-year period, then that's a fair comparison. And that's the logic behind this least common multiple of the service lives. The service life for alternative 1 was essentially 1 year. For alternative 2 was 10 years. For alternative 3 was 15 years. The least common multiple is 30 years. Right? You divide 30 by 1, by 10, or by 15, it comes out to be an integer. So the least common multiple of the service lives method, we take that 30-year period in this case and find the present worths. The calculation, the particular calculation, is then different from before. For alternative number 1, we've got the $9,200, taking the present worth at the 9% interest over 30 years, and that's equal to $94,511. For alternative number 2, we've got a $15,000 first cost today, plus a $15,000 first cost, but spent 10 years from now. So we have to bring that back to present worth from a future worth at 9% over the 10 years, plus the $15,000 spent 20 years from now. Those are all the first costs, plus those annual costs of $3,300 plus $400 plus $2,400 plus $300, brought to present worth from an annuity at the 9% interest over the 30 years. So this represents buying that second alternative 3 times. And if I work through the calculations there, I get $89,760. And for alternative number 3, again with the same principle, we're buying alternative number 3 twice. Once now, once 15 years from now. So we've got a $250,000 first cost now, $25,000 cost 15 years from now. And then the annual costs. $1,450 plus $600 plus $3,075 plus $500, brought to present worth over the 30 years. And the total there is $89,649. So using this least common multiple of the service lives method, we end up with present worths under the circumstance of repeating these purchases as many times as necessary over a 30-year period. And that's a fair comparison, even if we don't actually repeat the purchase, because all we're doing is deciding which one is the best one to buy, not necessarily committing ourselves to making these purchases in the future. And we see that alternative number 3 under this method is slightly cheaper than alternative number 2 and significantly cheaper than alternative number 1. And it would be the best choice on economic grounds. The second method of the 2 methods for determining the best alternative when the service lives are different is a study period method. In this case, we simply choose, if you like, an arbitrary period of time in which to make these comparisons. That period of time might be chosen for very practical reasons. For example, it may be very difficult to forecast the demand for a particular product beyond 2 years. So you might choose a 2-year study period and make a decision based on that 2-year study period. Or it may be for a variety of other reasons. But it's an essentially arbitrarily chosen period. In order to do the study period method, what you need is the salvage value of the project or asset at the end of the study period. So for example, in our particular case, if we chose a 10-year study period, then at the end of 10 years, alternative 1 is finished because it's just labor costs of the 10-year. Alternative 2 is also finished because it has a 10-year service life. But for alternative number 3, there's still 5 years of life left in the material handling facility. And there's value in that life. There's usefulness to it. If you perhaps took the equipment and sold it on the open market, you'd get some money for it. And that's the salvage value. And it has to be taken into account. And it's taken into account as simply income, if you like, received from an imaginary sale of the asset at that point in time. And it has to be estimated. You have to know that salvage value. And there are various ways of estimating that salvage value, which we'll discuss later in the course. But given that you know a salvage value, you can make that calculation. So for example, assume that the salvage value for number 3 after 10 years is $5,000. Then we can do a 10-year study period. We know the answer for that for alternative 1 and 2 because we calculated that before. So for number 1, from previous work, we've calculated that the salvage value for a 10-year period is $59,042. And for number 2, we calculated that the present worth, the present cost for a 10-year study period was $56,073. For number 3 now, we have the following calculation. First, we figure out the present worth of the alternative as $25,000 plus the annual costs of $1,450 plus $600 plus $3,075 plus $500 times the series present worth factor over the 10 years. But then we have to take into account this salvage value. Now that salvage value is money coming in. The money we have here is money going out, so we change the sign to be a minus sign. So it's minus that salvage value, which is 10 years in the future, brought back to today's money. So it's like, we imagine selling this thing. We get money for it. That changes the present worth of this alternative. And we incorporate that into the calculation by recognizing that we have a change in sign because there's money coming in, and bring that back to present worth. And if we do that calculation, we end up with $56,030. So it's a different approach, and sometimes it's more appropriate, depending on the particular circumstances the decisions are being made in. You will notice that I'm sorry, that's not the correct answer. That should be 58,987. You notice that it can also give different results. The different results are based on that particular choice of salvage value. However that salvage value is evaluated, it's going to affect that final present worth. So in this case, in fact, we see that the present worth of number 3, the present cost, is higher than the present cost of alternative number 2. And using the study period method, with a 10-year study period, with a salvage value of $5,000 for alternative 3, results in our best choice being alternative number 2, instead of alternative number 3 as it was when we did the least common multiple, the service lives method. So the choice of method here will affect the results. Choice of method and the choice of salvage value. If we had chosen a different salvage value, then that would may indeed change the best alternative. So just to reiterate here, in the present worth method, we are converting cash flows to present worth to make a fair comparison. There are several different ways of doing this, 2 of them in particular, the least common multiple of the service lives method or the study period method. Both involve a choice of a study period. The first one doesn't require the determination of a salvage value because we time the comparison so that we can complete as many iterations of each alternative as necessary so that they come out evenly. In the second method, the study period method, that may require the determination of a salvage value for one or more of the alternatives. That salvage value is incorporated in the calculation and allows a fair comparison, but the 2 methods may not end up giving the same result depending on that choice of salvage value. Thank you.